All right, everybody, let's go ahead and get started. I'm really excited to introduce our next speaker, Kat Traxler. In her day job, she focuses on cloud security at Best Buy, but she's also a cloud security researcher. She's been doing a lot of really cool stuff, checking out GCP, Google Cloud Platform, and she's been contributing to one of our SANS Sec 510 multi-cloud security assessment and defense course, and is getting ready to teach that very soon as well. So with that, I'm going to go ahead and hand it over to you, Kat.
Thanks everybody for joining me. Like you said, I'm Kat Traxler, security at Best Buy. In my day job, like you said, I do cloud security. And in my quote unquote free time, I do a fair amount of cloud security research with a predilection for all things IAM. I tend to have a strong pull towards these attacks that are based in the abuse of identity, since security is about trust, and trust is all about establishing and validating identity. If you want to advance 2 slides. Perfect. So in this talk, I'm certainly not going to be covering your classic bugs you might think of, like cross-site scripting or SQL injection. When I think of bugs, those are the things that I initially think of, but we're not going to be covering those type of bugs today. Those type of bugs, they require testing for things like injection flaws, and most certainly the process to uncover any of injection flaws within GCP would be against terms of service. More to the point, I think I have complete confidence in Google that they have a robust SDLC. And their APIs, they're going to be reviewed for syntactical flaws. They're going to be reviewed for those classic injection flaws through static and dynamic analysis. The kind of bugs that I'm interested in are the unintended consequences. Those things that can't be identified no matter how many tools you have in your security pipeline. I'm interested in logic flaws. In order to know what might be a logic flaw, we first need to understand how GCP is glued together, where the glue in GCP are the authentication mechanisms. So to aid in this endeavor, I'm going to lay out some guideposts, some universal rules to the road of GCP bug hunting. Next slide. One of the glues that holds GCP together is the feature of impersonation. Impersonation is a core platform feature, not a bug. It also complicates the question of who can do what with what resource. If I can impersonate a service account, it means that I can request and will be returned the access token for that service account by a public Google API. With that access token, I can then perform actions as if I was that service account with all of its roles and permissions. You, as a GCP customer, you can enable users or service accounts to impersonate service accounts. Impersonation is also seen in Google's infrastructure. Impersonation shows up in GCP PaaS services as the mechanism for orchestrating its services' backbone IaaS. You can catch glimpses of project-level impersonation when a Google service account, or also known as a service agent, is configured to impersonate one of your customer-managed service accounts. This type of pattern you're going to see all over again, over and over again, to allow Google and its managed offerings to do something, anything, on your behalf. Next slide. I'd like to think of the Metadata API as similar to the public API that's used during impersonation, but with a different set of preconditions to be met. When a piece of infrastructure is spawned, it's bootstrapped with the internal service called the Metadata API. By querying the internal service, you can return a whole host of information about that appliance. If you take compute, for example, you can query the Metadata API to learn its host name. You can query the Metadata API to learn what disks are attached to the instance, what identity the instance is running as, and yes, retrieve the access token for the service account that the compute instance is configured to run as. Applications, code, these things running in the execution environment will need access to the Metadata API if it needs to authenticate to other cloud services. As cloud security professionals, we all know that this is how infrastructure as a service works. This is the mechanism for resources to authenticate across all clouds. This is not a GCP specific feature. This is also how, quote unquote, serverless offerings work. The Metadata API example with functions is that when you deploy code to a function, what you're really doing is controlling code that runs in a container. Any code that you deploy could query the Metadata API for the service account access token and return it to the end user. So if we acknowledge that the inherent need for code, if we acknowledge that code has an inherent need to access its internal metadata API, then my first rule of GCP bug hunting is going to be really self-evident. Next slide. It's pretty easy to grasp that cloud functions aren't actually serverless. They are tiny bits of code running in containers and therefore would have access to a metadata API. But what about PaaS? These platform as a service offerings, what's their deal? If GCP is known for anything, it's known as a PaaS-heavy platform compared to AWS and compared to Azure. It has managed offerings for just about any technology stack or niche problem you're trying to solve. I promise you that even in PaaS, there's still underlying IaaS. It might be a compute instance, it might be a container, but there's an execution environment there powering that PaaS solution. Let's take a look at Cloud Build. This service Cloud Build is described in its marketing materials as a fully serverless CI/CD platform. Now, as you previously established when examining cloud functions, serverless does not mean no server. And as it turns out, when you compare cloud functions to Cloud Build, the underlying infrastructure is pretty much the same. Do you want to flip back one slide? Sorry, I'm throwing you for a loop here. Thank you. When you deploy a cloud function, the underlying container is a resource in your GCP project. Now, if you want to go forward one more. Now, when you submit a build to Cloud Build, that build occurs in a container. It's a piece of code in a container, but in a Google managed project. The only meaningful difference between these two patterns is where that execution environment lives. When you take a moment to examine the underlying infrastructure in a PaaS offering like Cloud Build, it's a little bit more obvious that even with PaaS, you'll still just end up with code running on servers. Next slide. And what does code running on servers need? A metadata API. Infrastructure as a service, functions as a service, platforms as a service, they all have access to the metadata API bootstrapped into their execution environment. Because the metadata API is structural. All cloud resources will need access to their metadata API. But I promise you that's not the interesting question we're going to examine today. What makes the metadata API a target for attackers? What makes the metadata API a target for attackers? Well, it returns an access token of the identity for which it's running as. If we start exploring the question of, well, what dictates an attacker's ability to return that token? That's my interesting question. Just because the metadata API is always there does not mean that it can always be exploited. If we take a look at another PaaS service, for example, Cloud Scheduler. Scheduler is a managed cron service that allows users to specify an arbitrary HTTP request that can be triggered to run on a schedule. You most certainly can, and I have, specified Scheduler to make an HTTP request to its internal metadata API. But unlike Cloud Build, there's no mechanism built into the product to return your HTTP response. That's the response that you would expect to contain your access token. Now, if we look at these two examples between these two PaaS services, Cloud Build and Cloud Scheduler, we can outline a scenario on what would make an API attractive to an attacker. Number one, if you can elicit the service to make an HTTP request to the metadata API. Number two, you can observe that response. Next slide. Retrieving access tokens from the metadata API is not as straightforward as making a simple HTTP request to a public endpoint, because the metadata API is an internal service. But remember, if you can overcome some barriers that I've outlined, there is no access control. There is no point-in-time authorization check on the metadata API. Now, if we compare that to the API used for impersonation, generate access token API, well, that API is public. There are no network restrictions. However, the ability to impersonate a specific service account is controlled by Cloud IAM permissions. So whether we're talking about a GCP service account impersonation capability, or we're talking about accessing the metadata API, try to remember that those two things are just means to the same end. Acquiring an access token and assuming all of the permissions associated with the service account. Next slide. Okay, so the fact that there is no access control on the metadata API isn't really the whole picture, which brings me to rule number 3. If you can access the metadata API without the act as permission, you are onto something. While it's not possible to check authorization in real time when the metadata API is queried, ostensibly access to the metadata API should be gatekeepered by the act as permission. And it makes a ton of sense to have some IAM permission controlling access to the metadata API. Because as we've seen, if you have access to a piece of infrastructure, you have access to its metadata API and the service account it's running as, and the roles and permissions associated with that service account. Next slide. Historically, there have been some gaps in the act as permission gatekeeper. Google has a collection of old school data engineering PaaS services. Cloud Composer, Dataproc, Data Fusion, Data Flow. Until January 27th, 2021, these services will allow a user to access the metadata API and retrieve an access token, all without being assigned the act as permission. These 4 services up here allow an end user to assign a service account to a compute instance. So check, we have the creation of an execution environment. And each one of these services, the compute instance will process our user supplied code. Check. It's the perfect recipe for extracting a service account, all without the need for the end user to have the act as permission. That is until January 27th. Google, in their wisdom, has acknowledged this default behavior can lead to, quote, unobvious and elevated permissions. Next year, this particular bug will be closed, at which time users will be required to have the act as permission on the runtime service account of that basket of data engineering products. Next slide. Some of the bugs that pop up in GCP aren't so clearly about privilege escalation, but more about side effects. The idea that if a user holds one permission, the execution of that action will trigger something unexpected in the platform. A good place to look for these knock-on effects of IAM permissions are around the fringes. In products that are not maybe fully integrated into the core platform or might be in some in-between state. I know it won't surprise you to hear that an organization's acquisitions can often be bolted on in a way that can lead to unintended consequences. In 2014, Google acquired Firebase. And Firebase is a unique collection of PaaS services running on top of GCP. It's a platform that got bolted onto a platform. When IAM permissions were introduced in GCP, the permissions included permissions for creating and managing Firebase projects. How Google describes this relationship between Firebase and GCP is pretty straightforward. They say that a Firebase project is a GCP project that has additional Firebase-specific configurations and services. But exactly what those specific configurations aren't exactly explicit. Okay, so when a user creates a Firebase project, some really curious things happen in the background. It turns out that a service account is created, and a fairly privileged one at that. That service account is assigned the service account token creator role in the associated GCP project, allowing for project-wide impersonation. Granting any entity the ability to impersonate another service account at the project level is a big no-no. That's the kind of project level binding that just flaunts Google's documented best practices for service accounts. And it goes against every principle of least privilege bone in my body. If you were to find yourself in a position where you had to audit GCP roles and permissions, would you ever think that if someone had the ability to create a Firebase project, that would translate in the ability to create a customer managed project, or I'm sorry, a customer managed service account with the ability to impersonate. I suppose this sort of a situation would be something that GCP would call unobvious. Next slide, please. Which brings me to my rule number 5, my understatement of this entire talk, which is your cloud IAM roles are not a complete picture of what you can access. If you follow the impersonation role bindings in your GCP org, you can outline a known paved path for lateral movement, a path for obtaining additional permissions through the ability of impersonation. This is a known path, and it can be painstakingly documented. But metadata API abuse and use, that's more difficult to quantify, especially since there's known gaps in the act as permission. Also, you have to consider a user's access to PaaS services and roles and permissions assigned to that PaaS service. And consider if a user can surreptitiously acquire any of these roles. If I've done anything in this talk, I hope it's to train your skeptical eye when asking the question, who can do what on what resource? Maybe even inspired you to comb through that long and ever-growing list of GCP services, looking for bugs, looking for unintended consequences, looking for unfortunate side effects. Next slide, please. If there's something I only glossed over here, there's a good chance I've covered it more in depth in my previous 2 presentations. This is my 3rd public talk with GCP in the crosshairs. This past spring, I recorded a SANS webcast called GCP Privilege Escalation, a Transitive Path. It's a deep dive into impersonation on GCP, describing some of the attack primitives and the use of impersonation as a mechanism for lateral movement. For the Forward CloudSec conference this past summer, I had a blast. I presented on GCP's primitive roles, owner, viewer, and editor, breaking down some of their security consequences. And if there's anybody out there in the audience who's just really looking for a good start here article on GCP security, I think Chris Moberly wrote probably the best one I could imagine. I wouldn't try to write a different one. In February, he wrote an article called Tutorial on Privilege Escalation and Post-Exploitation Tactics in Google Cloud Platforms. Google it, Bing it. I hope you can find it. And all of these resources on this slide are just fabulous reads and watches to help you get up and running in your understanding of the GCP resource model and security posture. One thing I will underscore and put an exclamation point next to, all of these resources have been published since February 2020. The age of GCP security research is young, not even 9 months old. I don't imagine that GCP is exactly like hacking in the 90s, but with so little attention on the platform this far, a bug hunter is bound to find plenty to keep them busy. Thank you, and that's all I have for tonight. I'm gonna stick around for questions and hopefully try to get my Slack back up and running.